Welcome back. We are going to continue our journey through Unit 1, and I said at the end of the last video that we were done with Chapter 1 in the textbook. That was a lie. That was a lie. I misread my notes. We are still going to be in Chapter 1 for this video. So if you look through some of the Chapter 1 homework problems and said, I don't know what that's all about, that's because I'm dumb and I told you wrong. So after this video, you should be able to answer all of the Chapter 1 homework questions. My apologies. I'm sorry. So, in the last video, we talked about our simulation of an activity where we determined that people were trying to choose between Coke and Pepsi, and they had a 1 in 3 chance of being right just by guessing. So we simulated the chance of how many students out of 15 would guess right, and we saw that the most common answer was 5 out of 15, or 1/3, but there was some variability involved. Pretty much anywhere from 2 to 8 seemed reasonable. Anything outside that range, anything less than 2 or more than 8, seemed to be unusual in one way or another. But we kind of left that question open. What would be an unusual amount that would convince you that some people could tell the difference between Coke and Pepsi? But we're leaving that to the side for now. We'll come back to those types of questions throughout the course. We'll eventually answer them as best we can. But there are a lot of things we have to set up first. I may have even used some words in yesterday's video that you weren't sure what they meant. And we're going to start nailing some of those words down right now. Starting with the word variable. Now, you might know what a variable is in math, like in algebra. Like if you have 2x plus 4 equals 6, x is considered a variable. I'm not sure why, because 2x plus 4 equals 6, x is 1. That's not variable. That's a constant, right? But that's what we use language-wise in algebra. In statistics, a variable is actually something that varies. So specifically, a variable is a characteristic that changes from one individual to another. A variable is a characteristic that changes from one individual to another. There are infinitely many variables out there. It all depends on what you want to know. My height is a variable. My weight is a variable. My age is a variable. My internal body temperature is a variable. How I feel today, happy-wise, from a scale of 1 to 10, is a variable. There are so many. And you just need to know that a variable is this. Something that varies from one individual to another. So think back to yesterday's activity. What was the variable in that activity? What is it that we were actually measuring? Whether someone could tell the difference between Coke and Pepsi or not. That variable is a characteristic of each individual student, and it changed from one to the next. One student might be able to determine the difference and pick the right cup, the next might not, right? A common misconception that I see in terms of identifying variables is someone would say that the variable from the activity yesterday was the proportion or the number of students who could tell versus those who couldn't. So like 5 out of 15 would be the variable. Those people aren't remembering the definition of a variable. It changes from one individual to another. So by definition, a variable has to be measured on every single individual. If you're talking about the number of students in a sample who could tell the difference or not, that's not a variable, that's a statistic because it describes a sample. And we'll talk more about that in the future. But for now, you just need to know a variable is measured on individuals and it changes from one individual to the next. So, a categorical variable we can classify variables in two ways. And those of you that took the one semester probability and statistics course, this is one of the first things we talk about in that course as well. So you might remember this a little bit. Variables can either be categorical or quantitative. Categorical variable takes on values that are category names or group labels. Okay. So, a variable is something that changes from one individual to the next, something we're observing or measuring. And a variable is categorical if it takes on values that are category names or group labels. So we're essentially taking individuals and putting them in groups. That's what a categorical variable does. So let's talk about some examples of categorical variables. We've got gender, and for the purposes of this particular lecture, let's just assume that the values of that are male and female. Okay, so if we are classifying people by gender, we've got males and then we've got females. We are labeling individuals with this variable. So that makes it categorical. Another one might be eye color. Okay. Some people have brown eyes, some people have blue eyes, some people have hazel eyes, some people have cat eyes because they're wearing weird contacts, whatever. Okay. We can place people into categories or groups based on this. We could do dominant hand. Are you left-handed? Are you right-handed? Are you ambidextrous? Can you do things with both hands? Okay. So we've got left, right, or ambi. Okay, we're still putting people into categories or groups. We've got age group. Now, age is something that can be measured in different ways, right? So you can measure someone's age by the number of years they've been alive. That's usually how we measure people's age, right? But what I'm saying is you could separate people into groups based on their age. Not just in terms of you're 10 years old, you're 15 years old, you're 90 years old, but you are young, middle-aged, or old, for example. We could create groups based on those measurements, and that would make that a categorical variable. Okay. Your grade in English last year is a categorical variable because I can group all of you by the result, but only if it's measured a certain way, right? If we're talking percentages, that doesn't necessarily put you into a group because chances are, unless you have the exact same percentage as someone else, you would be in your own group. But if we measure it by letter grade, now we've got people in groups. So I guess last year was kind of an odd scenario because you either had an A or an F, so there would only be two groups. But in a usual, typical year, you would have A, B, C, D, F. Okay, if you take out the pluses or minuses, right? So if we do it by letter grade, then your English grade is a categorical variable because it puts you into a category or a group. And there are others as well. There are infinitely many different categorical variables. They just separate individuals into groups or categories. That's what they do. The other type of variable is trying to find out which color marker to use. Let's go purple. Okay, so we have categorical variables. We also have quantitative variables. So a quantitative variable takes on numerical values for a measured or counted quantity. A quantitative variable takes on numerical values for a measured or counted quantity. So there's your main difference between the two types of variables. Categorical simply places individuals into groups or categories. A quantitative variable is numeric and is measured or observed. Okay. And in the probability and statistics course, I actually like their definition. It includes the fact that you can do arithmetic on the variable itself. So you can add, you can subtract, those things. Okay? But this definition is also useful. So let's look at some examples of quantitative variables. Numeric values for things that are measured or counted. Typical height. Right? Height is a quantitative variable. It's numeric. The thing about quantitative variables is they have units. So if you are given a variable and asked to classify it as categorical or quantitative, and you determine that it's quantitative, you need to specify the units. And this can be done in America in inches. Pretty much everywhere else in the world, centimeters or meters. Okay. Pretty much anything having to do with how much something costs, anything money-wise, is quantitative. It's numeric, and we can count money. In fact, it is some people's job to count money. So we've got that. We've got how much time it takes to do something, to do a task, to run 100 meters, to do your homework, how long this video lasts, hopefully not longer than about half an hour or so, okay? And this can be in seconds or minutes or hours or whatever, okay? We've got temperature. Okay. And again, you can use the units of your choice. In these parts, you'll be using Fahrenheit, usually. You might use Celsius elsewhere. There are other temperature scales that are a lot less common. But what these all have in common is that they're all numeric, and they're all things that are measured or counted. Okay? They're all numeric. That is really the dead giveaway for a quantitative variable. If it's not numeric, it's not quantitative. It's going to be categorical. That's a dead giveaway. That being said, it is also a mistake to say that any variable that is numeric is automatically quantitative, because there are things like zip code or student ID or things like that that are numeric, but it's not something that's measured or counted, right? Your student ID isn't something about you. It doesn't say anything about you. And if you were to take your student ID and someone else's and try and take the difference between them, that difference wouldn't make any sense, right? It doesn't make any sense to subtract. For a true quantitative variable, not only is it numeric, but it makes sense to take differences. That's really the point here. You can take the difference between two people's heights, how much two things cost, how much time it takes for one thing versus another, how warm something is versus something else. Okay? So you may be given a variable or a list of variables and be asked, is this variable categorical or quantitative? And you should be able to do that, hopefully. Okay. And for quantitative variables, you may be asked to provide the units as well. One more thing about these quantitative variables. Any of these variables could be measured in a way that would make them categorical. So any quantitative variable could be measured categorically. What do I mean by that? How could a variable that is quantitative become categorical? Well, height in order to make it categorical, we would have to turn people's heights, and instead of measuring them in inches, measure them in a way that puts people into groups or categories somehow. So one way we could do that is to call some people short, some people medium height, and some people tall. There are other ways to do it. You could have more than just these three categories. You could say these people are super short, then you have regular short, then you have medium short, then you have medium, then medium tall, then like super tall. The number of categories doesn't really matter. But the fact that you could take this measurement and turn it into a categorical variable by only reporting the group of the individual is what matters. You can do the same thing with cost. Cheap versus expensive. Again, the number of categories could be different. If you go to like any kind of rating website on the internet, they probably you can filter restaurants by how expensive they are. $1 sign to like $4 signs. Same idea. Okay. Elapsed time. Something could be slow or fast or somewhere in between, however many categories you want. Temperature. Cold, medium, hot. Okay. You can turn any quantitative variable into a categorical variable. What matters is not the variable itself so much as how it's measured. Is height measured in inches, or is height putting you into one of these categories? It depends on how it's measured. Now, some variables are stuck here. They're never going to be quantitative because they're not numeric. That's fine. These can't really jump over there. But these can be categorical depending on how the measurement goes. All right, so I'd like to go through an example from the textbook. You can bring out your textbook if you like, but I'm going to attempt to try and get an online textbook that I have access to as the instructor and put it on the screen so that you can read it there while I talk about it. So give me just a sec, and all right. So page 12, number 22, it's over here. That's where we are in the book. So take a look at that example, read it through, and unpause the video when you're ready. All right, so what we're doing with this problem, and you'll have, I think, 3 homework problems from chapter 1, similar to this one, where what you're going to be asked to do is identify the W's. Identify the W's. And the W's are who, what, where, when, why, and how. So, the reason that I'm having you do problems like this is because in this class, the context in which a problem occurs is important. Let me repeat that. The context in which a problem happens is important. If you're anything like I was in school, especially if you were to take like a standardized test or something, if it was a math test, it'd be like, Julie went to the store to get all these things, and she found this, and she found that, and what happened? So, that's the problem. You're like, I don't care about Julie. Julie doesn't matter to me. What's the answer to the problem? You circle all the numbers in the problem, you figure out what formula to use, and you get the answer. That's how math works, right? The context is just flavor. It doesn't really matter. But in this class, it does. In this class, context is what tells us what to do. All your answers need to be in the context of the problem. So, what problems like this one, I pointed in the right direction, problems like this one are for is to get you to start looking at the context of the problem. What are the variables? Who are the individuals? What's going on in the problem? Because while it may not seem super important now, by the time the year's over, the context of the problem, you could have two problems that look pretty much the same. But based on the context, you might do two severely different things. And it all depends on what the variable is, what kind of variable is it, and all of that. So let's get started here with this problem. It's over here. It's over there, right? And let's identify who this problem is about. Who is this problem about? Let me get my textbook, because I can't read that from where I am. I'm old, my eyes are bad. So we've got the EPA tracking fuel economy of automobiles based on information, and it has all this data. Okay, cool. All right, so let's talk about the who. Who is this problem about? And it looks like it's the individual automobile models. Individual automobile models. And maybe you would have come up with something a little different than that, but that's the main idea here. The what. What are the variables for this example? The variables are all those things at the end, right? So, I'm actually going to put these down here. So we've got variables. Manufacturer, vehicle type, weight, horsepower, gas mileage per city, and gas mileage for highway. I believe those are all the variables, all the things listed at the end there. Okay, so that's the what. This is below. Where is this happening? Where is this happening? Well, this may require a little bit of outside information, but the Environmental Protection Agency, the EPA, that is a United States agency. So this is happening in the United States, but I'll make a note, like if this were a homework question or something like that, I would note that that was not specified. I inferred that. I assumed it, but I got a pretty good idea it's in the US if the EPA is doing it. Who, what, where, when? When is this happening? There's no information provided on when either. And that's going to happen on some of these. Some of them will give you a specific time frame, a year or something. Others won't. So we can just say that this is relatively current. But again, that wasn't specified. Who, what, where, when, why? This might be one of the more important things to answer. Why the heck is the EPA collecting all this information? Why are they doing this? Well, they're tracking the fuel economy of automobiles. They want to track the fuel economy of different models. Okay. And that's good enough to put there. If you have the outside information, you would know that there are federal laws governing the fuel economy of different cars. I think every manufacturer has to have an average miles per gallon of at least so much among their entire line or something like that. Okay, the W's also do include how, which I think is fair because there's a W in how. Just because it's not at the beginning of the word doesn't mean it doesn't matter. So how is the EPA getting this information? They are getting this information from the manufacturers. So the data is collected from the manufacturers. Data is collected from the manufacturers, right? So that's all the W's. The problem also asks to name the variables, which we've done. That'll be your what. And specify for each variable whether its use indicates that it should be treated as categorical or quantitative. Okay, so we need to determine for all these variables, are they categorical or quantitative? And it depends on how they're measured in this context. So let's take a look at each one. There we go. All right, so manufacturer. So this is like Chevrolet, Dodge, Ford, Mercedes, Audi, right? That has to be categorical. So I'll just put a C next to it, and that's good enough for your homework as well. C for categorical. Vehicle type, and I believe it provides some information. Yes, so this is whether it's a car, an SUV, a truck, something like that. This is also categorical, right? We're putting cars, or we're putting automobiles into groups based on what type of vehicle they are. There's nothing numeric about either of these variables. The weight of the vehicle, does it give us any units there? It doesn't. No units. But if you know what the units of we're not the horsepower yet. If you know what the units on weight are, then you'd know that that's numeric. And you can take two different cars' weights and like subtract them or add them together. It makes sense to do that. So this is quantitative. Horsepower is also a numeric variable that it makes sense to do arithmetic to. That's quantitative. Gas mileage in the city, gas mileage in the highway, those are also quantitative. Also quantitative. So that is what type of variable each is. Do we have to do anything else? For any quantitative variable, identify the units in which it was measured, or note that they weren't provided. So for all of these, we have to say what the units are, or if they're not provided. So weight, not provided. Okay, so the units are not provided. It could be pounds or tons, I suppose. Usually pounds. Horsepower. I don't think the units were provided there either. Nope. Not provided. Funnily enough, the units on horsepower are horsepower. That is the unit. for horsepower. Gas mileage for the city and highway, it actually does say in the problem MPG, miles per gallon. For both of those. So, that is everything you would be expected to do for number 22, which is right here. And so you'll have, I think, the last 3 problems on the homework will ask you to do something similar, where you'll have to identify the W's, your what will be all the variables, so make sure you list those out, whether they're categorical or quantitative, and if they're quantitative, whether the units are not provided or what the units are. So I think that's pretty good for this video. This time I'm pretty sure this is the end of chapter 1. So all of the chapter 1 homework problems you should be able to tackle based on these last 2 videos. So go ahead and get those done. I will have virtual office hours. If you can't make those, get a hold of me. I'll make sure that you get the help you need, for sure. Even if it's e-learning, I will do it. So, until next time, we'll see ya. Have a great day.